Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to use the combined gas equation or gas law equation in order to solve problems. So when we're trying to decide if we're going to use the combined gas law equation or the ideal gas equation, you have to ask yourself first, is there some change going on with the gas? Is there a change in pressure, change in volume, a change in the amount of gas, a change in temperature, or a change in any of those factors, more than one of those factors together? Or is it just giving you the characteristics of the gas, or giving you a few measurements and saying, hey, here are some measurements of the gas. I'm going to give you pressure, temperature, and volume, and then can you tell me the amount of this gas, right? If there is no change going on in the problem, then you want to use the ideal gas law. If there is no change, if there is a change going on in the problem, then you want to start with the combined gas law. And I will show you how the combined gas law is really the only law you need to know uh, uh, to solve these sorts of problems. You have Boyle's law, you have Charles' law, you have Gay-Lussac's law, you have Dalton's law, all that. So if you know the combined gas law, then you can get to the other equations that you need to solve a particular problem. So let's get started. So here we have a problem where you're getting some changes in the gas. It says a standard neon gas container has a volume of 1.0 liters and a pressure of 101 kilopascals at 22 degrees Celsius. If the gas is allowed to expand, right, so we're changing the gas, if the gas is allowed to expand until the pressure is now 1.3 kilopascals at 19 degrees Celsius, then what is the new volume of the container, right? So the container or the gas is undergoing these changes, and we want to know what the new volume is. So the old volume we're set is 1 liter. What's the new volume? Okay, so this is obviously going to use the combined gas law equation. So let's write that down. So the combined gas law equation is P1 V1 over N1 T1 equal to P2 V2 over N2 T2. And so the P stands for pressure, and V is volume, N is the amount of gas in moles, and T is for temperature. And so the ones represent what you initially start with, and the twos represent what you ended with after the change. Now, the way you're going to decide what the equation you're going to use for your particular problem is to identify what is constant or not mentioned in the problem. If it's constant, you just simply get rid of it from the equation, and what's left over is the equation you're going to solve. Um, if it's not mentioned in the problem, then you can assume it's constant and get rid of it from the equation. So let's look at the problem they're giving us. So first thing I want to do is always label what they give you in the problem so you can identify what the initial and final values are of your gas. Okay, so for example, they say a standard neon gas container has a volume of 1.0 liters. Volume, so that's V1. That's what we're starting with. V1 is equal to 1.0 liters. Okay, and a pressure of 101 kilopascals. Pressure, that's what we're starting with. That's P1. So that's equal to 101 kilopascals. At a temperature of 22 degrees Celsius, that's our T1. So T1 is equal to 22 degrees Celsius. And remember, temperature is always going to be in Kelvin for gas law problems. So we need to add 273.15, and that's going to give us 295 295.15 Kelvin. Okay, so now we've got the V1, P1, T1, and it says if the gas is allowed to expand until the pressure is 1.3 kilopascals. So that's going to be our P2. So P2 is going to be 1.3 kilopascals at 19 degrees Celsius. So that's our T2. So T2 is at 19 degrees Celsius. We got to add 273 to that, 273.15. And that's going to give us 292.15 Kelvin. That makes sense because from 22 to 19, that's a decrease of 3. So it should be a decrease of 3 in our Kelvin as well. So we have a decrease of 3. All right, so we have our T2. And now they're asking what is the new volume. The new volume is our V2, right? So V2 is equal to question mark. We don't know. That's what we need to find. Now, look at the data. What is missing in the data that we're not given that's in our equation? If you said the amount of gas in moles, you'd be right. So they don't mention the amount of the gas. So we can assume that we're not changing that. The amount of gas is constant. So what do? You get rid of it from the equation. And then what's left is the equation you now are going to use to solve the problem. So now all you need to do is plug in the values for each of these. You don't need to change the values of your pressure and volume. All you need to do is make sure that they are the same unit. So if you got different units, you do have to change one of them so that they have the same unit as the other. But you don't need to change them to a particular unit. As long as they're the same unit, they will cancel out anyway. Okay, so now that I have all of the data, I have my equation. Now all I'm going to do is plug everything into the equation. So I have P1. So my P1 is 101 kilopascal. So I have 101 kilopascal multiplied by V1, which is 1.0 liters. So times 1.0 liters. And that's going to be over my T1. My T1 is 295.15. So 291.15. Did I say it right? 295. Sorry, 295.15. 295.15 Kelvin. Okay, so now I got that side. Now this side I have P2. My P2 is 1.3 kilopascal. So that's going to be 1.3 kilopascals. Okay, multiplied by V2. V2 I don't know. That's what we're looking for. So I'll just put V2 in there. We don't know. That's what we're going to solve for. And then that's all going to be over the T2, which is 292.15. So 292.15 Kelvin. So now all I need to do is solve for V2. So I'm going to multiply both sides by the temperature here. I'm going to divide both sides by the pressure. And so I get V2 is equal to, and this is going to be 101 kilopascals over, or multiplied by 1.0 liters, multiplied by this temperature here. So I'm 292.15 Kelvin. And then I'm dividing by 2.9. Oops, not 2.95. Sorry. That's going to be 295. So I have the 295.15 Kelvin now multiplied by the 1.3 kilopascals. So now I double check my units. Everything should cancel out except for a volume unit, which is going to be like liters. So the kilopascals I have on the top and the bottom, that cancels out. I have Kelvin on the top and the bottom, that cancels out. And all I'm left with is liters, which is what I'm expected. So now all I need to do is calculate, and I get 77 liters. 77 liters of this gas. That's the amount of gas. That's the volume of the tube if it were to expand. Okay, so now what about the sig figs here? It's got two sig figs. So for those of you who are interested in sig figs, remember that when you're multiplying, dividing, the number of sig figs in your answers should be the same as the least number of sig figs in your measurements. So we have 3 sig figs here, 2 there, 5 there, 5 here, and 2 here. 2 is the lowest number, so you're only allowed to have 2 sig figs in your answer. Okay, let's go to part B. Now, part B is saying how many 500 milliliter tubes would this gas fill? Okay, so we're given 77 liters, and we know how many 500 milliliters tubes would this fill. So what we need to do is convert. So we want to know the number of these tubes. So we have 77 liters. So we need to convert 77 liters of gas into tubes, the number of tubes. So I'm going to put this over 1. First thing I want to do is convert this to milliliters. Since I have milliliters there, I'm going to convert to milliliters. So I know that 1 liter, or we could do this way, liters is going to go on the bottom because I have liters on top. I know that 1 milliliter, milli means 1/1000th. So 1 milliliter is 1/1000th of a liter. So that's going to be 10 to the negative 3 liters. You could also say that 1 liter is 1,000 liters. It's the exact same thing. So if you use 1 liter and 1,000 milliliters, that would be the same ratio. All right, so here we have liters canceling out. I have milliliters. Now I've converted to milliliters. Now I can use this as a conversion factor. 1 tube is how many milliliters? 500. So I can use that as a conversion factor. So 500 milliliters is going to go on the bottom, and 1 tube is going to go on the top. So milliliters cancel out. Now I have tubes, the number of tubes, which is what I want. So now I'm done. And when I calculate this out, I get 1.5 times 10 to the second power of tubes. Let me double check that. Yep. Tubes. Can't forget my tubes. And so now we see that it's about 150 tubes will be filled by this amount of gas. And that, ladies and gentlemen, is how you use the combined gas law equation in order to solve your problems. So if this was helpful, well, not all your problems. I mean, there's some problems like, money problems, financial problems. That's not going to solve it. Anyway, bad joke. So anyway, if you enjoyed this video, if this helped you with the gas law problems, please, by all means, like the video, share the video with your friends, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell. And then when you do, make sure you click all so you'll be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Also, if you have a particular problem or question you want me to help you with, or if you have a topic you would like me to cover, I would love to do that for you. Thanks for joining me and have a great day.